Welcome to the podcast. I'm Laszlo, and today we are going to be discussing biomimicry in manufacturing. Specifically, we're going to be talking about the Cholla cactus. So let's start with a brief overview of what exactly biomimicry is to begin with. So this is essentially taking reference from nature in order to contribute to new technologies or new innovations in the industry, such as manufacturing. And a great example of this biomimicry is the Cholla cactus. Now, what is the Cholla cactus? The Cholla cactus is a cactus, and it's native to northern Mexico and the southwestern United States. So it grows up in very arid desert environments with high winds and sand, so low moisture. They are spiny on the outside and have very hollow interiors. And now, this hollow interior is the important part and where the biomimicry comes from. This hollow interior is beneath a skeleton structure that supports the entire cactus and helps it resist the very high winds of its environment. This means it has very high strength against torsion forces and shear forces while being extremely lightweight. This makes it an incredibly efficient and lightweight structure that exists entirely in nature. And this hollow structure is also the most important thing for the biomimicry uses that are seen in the industry. Now, using the Cholla cactus in manufacturing is a very new development. The most recent studies have been around 2019, when the University of California began researching its application in car roll cages. Impact testing and crash testing was done using roll cages that were inspired by the Cholla cactus's hollow interior. And so the roll cages were built up with the patterns that were seen in the Cholla cactus, and then they were implemented in these tests in order to see how much force they could retain, how much flexion was had, how much torsion could be resisted, and how much the impact was distributed throughout the body. And this study found that the Cholla cactus was actually the most efficient of all the example roll cages. The internal structure that already exists in this cactus was distributing the force in a much safer way than any kind of roll cage that already existed and was being tested. As such, they concluded that this structure that's found within the Cholla could definitely be implemented in structures that have to have high force, high torsion force, and also be lightweight. Being able to resist forces and additionally being lightweight is something that can apply to many, many different industries because having these traits is a priority for a lot of applications. For example, while still discussing the automotive standpoint, this could definitely be implemented into off-road vehicles, as well as potentially spacecraft such as rovers. However, automotive isn't the only use for these kinds of structures, as these traits would be also very advantageous in aerospace applications, where the lightweight and high resistant structure, especially when it comes to shear forces, which it was highly resistant to, are extremely important in aerospace engineering. But beyond vehicle applications, there are additional manufacturing uses that were studied, particularly by two universities in China, Hunan University and Fudan University, which collaborated with the Chinese Academy of Sciences. And these two universities produced two very landmark studies, both in 2023. One of them studied advanced composites inspired by biological structures with a focus on architecture design. And so it was found that among the chosen things to study, the Cholla cactus had extremely high variable use in architecture design, meaning the structure could definitely be implemented into buildings, which would create a very strong structure without necessarily using the same amount of materials as traditional design. The other study by Hunan University focused on the crashworthiness analysis of cactus-inspired structures under axial crushing as a response to the study that was done by the University of California. Not only did this study confirm the active force distribution of the Cholla cactus structures, but it also added additional statistical information such as improved structural mass, wall thickness, loading velocity, and cross-sectional configuration compared to traditional structures, with tests improving in capacity by 28.3 to 127.9%. As such, this structure was highly recommended for applications in vehicles, aerospace, marine engineering, and in combination with the other study in now architectural engineering. So you have this cactus from the high wind desert that has naturally created a very resistant structure within itself, this Cholla cactus skeleton, and are now seeing how it can be implemented into manufacturing structures and into product structures to make them stronger against torsion forces, shear forces, and better at general force distribution, while being extremely lightweight and extremely efficient in the amount of material used when compared statistically to more traditional structures. However, there's a caveat to this, being that this kind of Cholla Cactus structure has not been implemented very widely into active industries and is still being researched for its applications. It's a very new development, with these studies ranging from 2019 to 2023 or 2024. So there's a lot more work to be done to see just how far this structure can go as far as supporting new technology. Many of these studies conclude by suggesting that there should be more research put on how this structure could be used on a much smaller, microscopic level, so they could be potentially used for precision tools. This would be very big for manufacturing, where you would be able to use these structures within machines, where a lot of forces are distributed over time, potentially increasing the lifespan of automated systems or increasing the capabilities of them. Or even then, reducing the amount of material use within the actual design. This is especially important because cost, effectiveness, efficiency, volume, and lifespan, all of these are extremely big factors in manufacturing, and especially automated manufacturing, where machines are very dedicated to creating products and doing output as compared to people. So implementing this example of biomimicry could prove to be a big development for the wider industry. However, that is not quite the case yet, and so there's still a little bit more room to be done. Personally, I'm very invested in the lifetime of the Cholla Cactus studies and what it might be used for in the future, because I'm somebody who wants to go into these fields and is very interested in automotive engineering, where this is a increasingly common practice. Overall, biomimicry is a very cool way of implementing new technology with reference to nature, and the Cholla cactus, which exists in these high wind environments and is very great at distributing and handling forces, is an excellent example of this being put into use.